Good morning, everyone. Am I audible? First class will always be late only, I think. The bus doesn't arrive early and we are late. Am I audible? Okay. Yeah. So, discuss where we had left. Anyone? Till where we have done? Anyone? Tassi, Chosun, where we have left? This constants we have done, or the water pressure, till water pressure, or what? Or we have done till here. Hmm? This one we have done, the constants. This one, the constants, modular ratio, lever arm coefficient, moment of resistance factor Q, moment of resistance factor, water pressure on the for the continuous frame action at the top. That means We had how much? 3.70, and the bottom portion 1 meter. This one 1 meter was for your cantilever action here. Till where we have done fix and moment we have done. Hmm, tell me someone. Which one? We have not done. We have okay. Okay, we have done that means lash round. Okay, neutral axis coefficient we have done this we have done pressure we have calculated the pressure water pressure which is acting on the top portion which is gamma W into H. Gamma W into gamma W into H, and H was our this much, capital H minus small h. We have got the pressure to be 27 kilonewton. Now we had to do the friction moments, right? What we were doing for the this portion, what we had done here, if I have showed you or not, but I suppose this was a rectangular water tank. Now, if you have here with the straight line, if I show you, hmm, this portion was how much? 6 meter. We also have here this side. Six meter. This was 6 meter. This is 3.7 meter. Right. The this was the length and this is the height. Okay. This is the height of your this thing along the longer wall. We are looking along the longer wall. So this is the longer wall and this is the height. 3.7 we had got. 3.7 meter. Then we had this 1 meter where it went. Whatever the 1 meter was our cantilever action here. So suppose this is your 1 meter here somewhere. Hmm. This is a 1 meter. We have here. Hmm. So now from here to here you have this much. Here you have 2.7 meter. This is a 1 meter, which we know that this portion here what is happening, this one, this is nothing but your loading for the frame action. Loading for the frame action, then we have This one is how much? This one, the total pressure which is acting, that is how much? The pressure, water pressure, 27 kilonewton per meter square. Kilonewton per meter square. And this portion here, this is your loading for the cantilever is here. Loading for the cantilever action. So, this is nothing but yeah, this is the straight. This is straight. Okay, straight line, dotted line here. So this was how much here? So it's 1 meter, 3.7 meter. Okay. So this was 27 kilonewton meter. The pressure, water pressure acting here is 27 kilonewton per meter square. Okay. So from here, you know this is the water tank here. This is the height here. Here we will have the pressure. The water pressure action is how the loading. This upper portion we are going to design as a frame action, the continuous frame action, and we are going to design this 1 meter portion as your cantilever action here fixed here, and here this wall is can move. So now what is the water pressure acting here? It is 27 kilonewton per meter square. Okay, now once we know this is suppose point A. Okay, this is just this thing. Okay, from the longer side we are viewing, longer span along the longer span we are viewing. But now, if we see the plan, from the plan we can find out the friction moments here. Okay, these things will get erased now. Okay, so if we go bottom here, you will see friction moment. This is your longer span of the a rectangular tank. This is the shorter span 4 meter. Here the water pressures are acting here. These are your water pressures which are acting on the wall from all the four sides on the inside portion. Okay. So these are the water pressures which are acting on all the both the walls, longer and the shorter walls. Now the friction moment, this how we will find out the friction moments here. That is at A point, at A, friction moment at A when your B is movable. Okay, and when your friction moment when your A is fixed but your D is moving. So that is how much your moment is WL square by 12. So W, you know, it is your 27 here. The pressure which is acting, that means PL square by 12, that is W. The pressure which is acting here, it is 27 kilonewton per meter square. L, you know, for the AB portion fixed and moment AB, it is your 6 meter. For the fixed and moment AD, A is fixed and D is movable. The moment is acting here on D. So that is how much P L square. This is 4. P is 27 kilonewton per meter square. L is your, this one is 4. Okay. 4. 4 meter square. Then we have why this is negative here minus W, that means PL square by 12, and here it is positive PL square by 12, because you see here when you are finding out the fixed moment here FAB, A is fixed and B is moving. So now water pressure is on this wall B. So on this portion AB, this member AB, your water pressure is here on this wall. So A is fixed, your B is going to move in this way, the moment is in this way. Right, and your fixed moment A is fixed and your D is moving. So due to this water pressure, your D is going to come out, your moment is going to be in this way. Right. So you see here your B member here. What is happening when A is fixed? Your moment at B is anti-clockwise, so it is negative. And here at AD, when your A is fixed and D is having this moment, so that is clockwise moment, so that is positive here. Okay. So fixed and moment AB, your B is moving anti-clockwise, so negative. AD, your D is moving clockwise. Moment is clockwise, so it is positive. Now, when we know the fixed moments, we can find out we can do the moment distribution at here at the point A, joint A. So joint A, your members are how many? A B, A D, A B, A D. Now we know what is our stiffness. We have to find out now what is our stiffness for EI by L. We know this one 4EI by L. So for the member AB, 4EI by L. EI by L is same. So L is how much? For AB, our L is 6. So this is going to change. So we got stiffness for member AB to be 0.67 EI. EI. And then we have for the member AD 4EI by L. L is how much? L is your for AD. It is 4. So 4 here. So that gives us to be our stiffness to be 1 EI. 1 EI. So now what is the summation of your stiffness? This plus this will give you obviously your summation is how much? 1.67 EI. This one 1.67 EI is a summation. Now we are finding out the distribution factor, moment distribution factor here. So what is the moment distribution factor? That is given by A by summation of K. The distribution factor here is for this member AB is K by summation K. So what was your K? Your K was 0.67 EI by 1.67 EI. That will give you your distribution factor to be 0.4. And your for this member AD, you will have how much? Your summation of sorry, KK is EI by 1.67 EI will be your 0.6. Okay, the distribution factor. Now, once we get the distribution factor, we can do the moment distribution, right? This was a joint here. We have calculated our this one distribution factor. Now we can find out the moment. We can do the moment distribution. Hmm. So the moment distribution here, how much? Your this is your A point, your B point, AB member, AD member, or the other way you can take AD, AB, whatever. But now here it is done like this, like A and B member is taking this side, AD is taking this side. Okay. So we know what is our distribution factor. Here at point A, we have got our distribution factor to be this one, 0.4 for AB and 0.6 for AD. Right. So 0.4 for AB and 0.6 for AD. Okay. So fixed and moment here. After that, we have to find out now. We know the fixed and moment here. This one. Fixed and moment we have calculated for AB. For AB, it is minus 81 kilonewton meter. For AD, it is 36 kilonewton meter. So for AB, minus 81, this one. For AD, 36. If the fixed moments here. some moments. Now the balance will be how much? Now the balance, how you are calculating the balance, this we know. How much is your this one? Balance, how it is going to come out is minus 18. We have this 81 plus 36 into your this plus this into your this will give you your this, and this plus this minus 81 plus 36 into this is going to give you this 27. So we have got minus 81 plus 36 into 0.4 is equal to minus 18. This plus this into this 0.6, we have got it to be 27. Okay, so what is our balance now? This minus 81, the signs are going to change. So minus 81 plus 18, that will give us 63 minus 63. Then we have the balance, then we have 36 plus 27, we will get 63. Okay. So now what is our moment at the friction moment, at the support? At the support, what is our moment? 63. We have got our moment at the support to be 63 kilonewton meter. This one, bending moment at the end support is 63 kilonewton meter. After we have done the moment distribution, we have got this much. Okay. This is plus. Okay. So now we have calculated the moment at the end, suppose 63 kilonewton per meter, 63 kilonewton meter. So now we will be calculating the moment at the center of the longer span EP. And now what is the bending moment at the center? This was at the end support, our moment at the end support. And now we'll find out what is the moment at the center. What is the moment at the center? So the bending moment at the center of long span AB is WL square by 8 minus your friction moment A at A, the moment at A. So that is how much? Your W is 27 into 6, your longer span is 6 meter. 6 meter. So W is 27. Then we have 6L by L square, 6 square by 8 minus our 63. Or W 27 into we have the longer span 6 whole square by 8. Okay, minus our moment at A is how much? At A and B it is all end supports are 63. So 63, that gives you your answer to be this one, 58.5 kilonewton meter. Okay, so the bending moment at the center of the longest one is how much? 58.5 kilonewton meter. Now, similarly, the bending moment at the center of the short wall you have to calculate, and that is again given by WL square by 8 minus MA. Along the longer wall, we are considering AB. So, now the shorter wall we are considering. So, WL square by same thing, 27 into now the shorter wall. So, your L is going to be so here this L is going to be 4. Then we have the ME. ME is again we know N supports a 63. So 63 here. So you will get after placing the values, you will get the bending moment at the then we have got bending moment at the center of the short wall to be 9 kilonewton meter. Okay. So we have got the bending moments at the center of the long wall, short wall. Now we also have to find out the tension. Okay. You see here, this is a little bit wrong. Okay, I'll just show the annotation here. This is okay. So now if I show you, so we have our at the end. Suppose this is point A, B, C, and D. So we have 63 here at this point. Yeah. So 63 here will go in this way. 63, 63 here it is 58.5. Then we will have here, yeah, this will be, draw the diagram clearly. Okay. So I would not draw a line like this. So this is 63 at the support. Here we have 63. Here we have 63. Here we have 63. At the end supports we have all 63, 63, 63, 63. So and here at the center we have seen what? On the center, this one, center of the long wall is how much? This one, 58.5, 58.5, and at the shorter wall is how much? This one, 9 kilonewton, 9 kilonewton meter, 9 kilonewton meter. Here this is your, this portion is negative. Here also this portion, this one is negative. Here also this one is negative. Here also this one is negative. Okay, and these are positive, so outside here. Okay, on the positive side. So 63 kilonewton in this way. This is your moment on this is your moment along the longer span and the shorter span. This is your A here. We have here B, C, and D. Okay. So we'll do one thing. We'll continue in the next class. Like candle G. Section B. Rahul Barua, 44. Okay, Rahul Barua, 64. Please
64.
65,
65 present, ma'am.
67, 69,
Present, ma'am.
70,
67 present.
70, 72, 73,
73, ma'am.
74, 75,
Ma'am, 074.
75,
75 present, ma'am.
76, 77, 78,
77, ma'am.
78, 81, 82,
82
83,
present, ma'am.
83,
Present, ma'am.
84,
84 present, ma'am.
85, 88,
Present, ma'am.
89,
89 present, ma'am.
91, 92, 93,
Present, 91 present, ma'am.
93,
Present, ma'am.
94,
Present, ma'am.
95,
95 present, ma'am.
96,
Yes, ma'am. 96.
98, 99, 100,
98 present, ma'am.
100,
97.
okay, 100,
Ma'am, 9.
97. Most of the classes you're absent only, na? Manish Das.
Yes, ma'am.
Why?
Ma'am, I was busy in a construction work, ma'am. That's why, ma'am.
Okay, I thought you're not there only, this person. Okay,
No, no,
then.
ma'am. No, no, ma'am.
Okay, 100, 102, 110,
102, ma'am.
102, 112,